welcome guys, especially for the people behind SoftTest. Yeah, welcome. It's a beautiful day outside, so I'm very impressed for you to come into a building when it's sunny outside, so thank you so much for coming along. Today we have two speakers tonight. We have Robert and we have Gareth, who have very kindly put presentations together for you. I'm just going to start with a big thank you for our sponsors. So Software SkillNet, who have organised the room for us, they organised the tea and they organised the coffee as well. So big thanks to them, we wouldn't be here without them. So the format, so tonight's agenda, I'm going to introduce our new website, just in case anyone hasn't been on it yet. And I'll talk about the one-day conference as well. We're currently in the planning stage for. Then Rob will speak for 30 minutes on his topic. We'll have a 5-minute Q&A afterwards for Rob specifically. And then Gareth will have 30 minutes and then a Q&A for Gareth then afterwards. So just a note on our website. So we've gone through a redesign, and you might have noticed that our logo has changed a little bit as well. So I would encourage you to have a look. So it's got presentations from our last events on the website, and then we're hoping to put a video up for the first time as well. And just a small note on our one-day conference. Hands up, who's been here to one of our one-day conferences? Wow, two, great. Did you enjoy them? Yes. I enjoyed them because then, so I felt comfortable asking you that then as well. So this is our third year of hosting a full one-day conference, and the last conferences have been very successful. We've had some great speakers coming in from abroad and from Ireland as well, and we host a series of talks and workshops as well. So if you want, you can ask Naomi and Will? Peter, any questions about it then as well. So the date is confirmed for the one-day conference, so Thursday the 19th of October, and it's going to be in the same place that we held it last year, so the Hilton Hotel in Charmouth Place, so just up the canal here as well. So save the date, and we'll send out more details when the programme has been put together. So I'm going to hand you over to Rob for the first talk of the evening.
Okay. So, if you graph it, they will see it. Splunk at Murex for test and development. That's the name of the talk. And it's going to be 30 minutes, as Claire said. What I'm going to do, first of all, is just give a quick overview. Well, who am I? Who is Murex? Okay, so this is the company we're talking from. Myself and Gareth are talking tonight. What is Splunk? Okay, why are we talking about the Splunk? Murex had a problem. Describe what the problem was. Okay. How we use Splunk for test and development, so basically how we use Splunk to fix the problem that we had, and then I'm going to show some use cases of how we got over the problem, basically using Splunk with the traces that we had. Okay, so now very quickly, who am I and what am Murex? There are only 2-3 slides, so I'm not going to try and sell you Murex or anything. My name is Robert Lynch. I'm the global Splunk manager at Murex. I'm also a non-functional test manager. I've been working with Murex maybe 13 years. I primarily do production, development, non-functional testing and production crisis. So very quickly, what's non-functional testing? I'm probably talking to a lot of testers here, but just to make sure, I always assume everyone knows nothing in the room. Like if you get a developer to build you a button, 2 buttons, and he only delivers you 1 button, that's a functional problem. Functionally, he has not given you that button. But if you press that button and the whole back end falls out, the CPU goes crazy and the system crashes, that's generally a non-functional problem, okay? It's a technical problem on the backside, okay? And that's the very quick way of doing it. Now, I don't deal with the functional problems. I deal generally with the garbage collection, the heavy CPU, we'll be doing big tests on big machines, and basically anything technical falls on my desk, basically, okay? So, what do Murex do? So, and this leads on to what Murex do. So, we're around about 30 years in our domain. We're 45,000 users and we're 250 clients in 65 countries, with 3 regional hubs, 17 offices, about 2,000 staff. the main thing to concentrate on is 1 billion invested in R&D over the last 10 years. So why is that interesting? It's interesting because it gives me as a test manager budget to go out to the market and get third-party software like Splunk, bring it into Murex and do a POC on it, okay? That's why it's interesting, okay? That's just a quick location of where we are. You never see the word Murex on billboards beside Nike. We don't usually advertise like that. We go into major investment banks globally, okay? So some of the biggest banks in the world would have Murex, basically, but they don't tell people that they have Murex because it's a trading platform. So what is a trading platform? When you have a trader in New York booking a trade, 1,000 Japanese yen, and he's a guy in Japan who wants to take that trade in 3 days' time, they need to book it on a software, okay? And Murex provides that software. So Murex will run mathematics to work out how much the trade is going to cost. Then the trader would agree the trade. The trade then gets booked into the Murex system, okay? And basically, in a very, very high-level way, that's what we provide these big banks. The ability, these big financial institutions, of how we can trade and how we can store their millions of trades or hundreds of thousands of trades, effectively making sure that the money they have, they're not overspending or underspending, or they're getting exactly the market value that they want for these trades. So this type of business is big business. All the investment banks have this, all the traders you see in all those Wolf of Wall Street, they all use this type of software, basically. Okay? Not necessarily always Murex, there's many different types, but we're one of the leaders in the financial institutions. Okay? What we do in the Dublin office is we do something primarily called the limits. Effectively, when you hear things like Société Générale, you hear a trader who lost 90 billion of the bank's money. And you go, how could that ever happen? Like, surely they have systems that stop that. Effectively, in Dublin, we do the limit system. So when a trader tries to book a trade that isn't possible, the bank physically doesn't have this money, the limit system is supposed to stop them and say, no, you can't do that. Okay? So that's basically what we do in Dublin. In the Paris office, they generally make the front office, so when the trader's actually making the trade. Okay? So there's kind of two systems. You have the front office, the trader's making the trade, the limit system at the back end, ensuring that the trade is viable for the bank. Okay? And it won't break the bank, basically. Okay? And when you hear these things, ING Barings went underground, same situation. The one trader had access to both systems, and he could push it through, and no one knew. And then all of a sudden they realised the bank is insolvent. Basically, there's actually no money left. So this thing still happens. So this is why the system's important. Now, what is Splunk? Splunk is a third-party software. Okay, so we are Murex, or financial software. Splunk is a USA company. Been around maybe 10 years. About 3 years ago, I was at the Eurostar test conference. Some guy had a problem, and the problem was he had to monitor 50 machines for his testing, and he had a problem here. It would push onto a problem here to here. The output would come onto this machine, but it said it would take him a day or half a day to unwind all the logs. Okay, to unwind all the logs, and he said he used a big data tool. Now at the time he never said what it was. After I went up and said, what tool did you use? He said, I used Splunk. Effectively, I had the same problem. When Murex goes into a bank, it can sit on 10 machines or 20 machines, okay? A big financial application. And when I'm running my tests on this software, I have to be able to monitor 20 machines, and that's a lot of data. Data just pushing everywhere. Logs, GC, CPU, network, everything. Just data pouring out of every of these machines. And it's impossible for one human being to look at all that. You just can't. Or you can spend all your day trying to rewind logs, okay? So this is why a system called Splunk is very good for that. So effectively, any data that's pushed out the back end can be ingested into Splunk. It doesn't even have to go to a file, it can be on the wire. And then what you do with that data is where things get interesting, okay? So effectively you have Murex, financial application, pushing data out, Splunk, reading the data, and now I'm going to show you what we did with the data, okay? Now, the development at Murex is simple enough. Well, simple enough is that we've about 5,000 Unix machines at Murex. We've about one box with host Splunk. We've developed nice widgets, so I've developed nice widgets, that in 20 seconds, any developer can add their environment onto Splunk. So, on one of those boxes you might have, whatever, X number of a test environment, a production environment. You could have any number of environments on those Unix machines. A developer's working, he rolls a quick widget, and then he logs into Splunk, and he can see the data from that environment goes into Splunk, and then it displays. I'm going to show you what it displays in a minute. The second thing is the log drops. So again, I developed a nice way. So our clients are live in production. They have a crisis. They have to basically get their logs to us fast. So they FTP them up, they send them to us, and again we have a nice way, or internal testing. We zip and tar them, and they go straight to Splunk, and then any Murex employee can access it via web, and then they get access to these nice graphs. So basically you might get an indicator, green, orange, red, there's a problem in log X, that's hit a breach of some sort, you need to look at that. I get an email in my inbox saying there's been a breach on client X has loaded in the oak, because what I've done is I've loaded in mathematics and I monitor, so I'm not going to bore everyone with garbage collection of CPU and network, but basically is you can kind of quantify these logs, and then you can say if you hit a threshold of a certain problem, like the client is in trouble there, like they might crash tonight, you need to act now, basically. So they would load in the logs here from the client, goes through, I get an alert, these are just kind of graphs that you can display, basically, okay, but I'm going to show you many more graphs, and that's effectively how we used it for phase 1. For phase 2, the developers got very interested in it, so the consultants were using that, and they were saying, well, can we use it for more test and development? And we said, yeah, sure, why not? So we already had something called TPS tracing. So TPS tracing is a performance log that comes out the back of our software, okay? Very simple. We write in Java in Dublin. Java has some very simple functions. You have a class, you have a method, you have a start time, and you have an end time. Now, why are we so interested in this? Any financial product, is one way any financial product will get removed from an investment bank if it's slow. Okay? We are really, really interested in performance. Like, performance is absolutely paramount to us. Some of our KPIs from our clients are absolutely critical. If we go over the KPIs, you'll be out of the bank within a year. So you have to be very, very on top of performance for these big banks. Okay? So to monitor performance, you need a good monitoring system. Okay? So the system we had about 7-8 years ago was TPS tracing, and we developed a system that it could monitor any class.method, because we write in Java, so it's class.method. And this particular case, this particular method took 5 minutes. Okay? So this is time on the y-axis, measure time. On the x-axis is real time. Okay? So that's fine. But however, usually if you're trying to say get that down from 5 minutes to 30 seconds, this class in any code line would have called thousands of other classes, possibly, right? Not just one class. It's usually not one class, one method that took 5 minutes. It would have normally called another method over here. So effectively, this guy took 5 minutes, but this guy called this 6,000 times, and you get this 50 milliseconds, bang, 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 and it goes all the way here. So it started at 22:05, finished at 22:10, and effectively what you have is a situation like this. Class.x, method.y was called once, took 5 minutes, total 5 minutes. Class.a, method.b was the count of 6,000 times, 50 milliseconds per, took 5 minutes. So you're going to give a developer a problem. So we use this in product development, and that needs to be 1 minute. So he can't debug the top one, because it's only called once. Or when he starts debugging it, he soon finds out very quickly, well actually, I need to get this 50 milliseconds down to 10 milliseconds. So therefore he opens up that class, and he starts wondering, how do I make this faster, basically, okay? So ideally, you run a test, the test comes out, you get your results, and then from that you go, we need to analyze and debug in this. Now some people might push back here and go, it sounds like JProfiler. So you have these tools in the market you can buy, and you run a test, and you JProfile it, and the JProfiler will tell you what class that method took the longest time. I say, well that's fine, but the problem with JProfiler is simple, is that if you put a JProfiler on that test, that 5 minutes goes out to 25 minutes, okay? And you can't put JProfiler in production. So what you have is a system now, is that we have a system now that at Murex, for product development and client testing, we can monitor any class.method. But then more importantly, when it goes to UAT at the client site and production at the client site, these traces are still pouring out. So if the client has a production crisis, if there's a real problem, the trades are taking more than a minute, and the traders are going crazy, you get a log drop that night, and straight away you have analysis of what's slow. Basically, that's the whole point. And we developed this 7-8 years ago, and that was fine. for a major client in London. But we had a problem. The problem was simple. The more popular this TPS tracing got, we produced, this is the report we produced. It was the old school report. Again, you have time there. It's a PDF, it's a static report. Okay, the TPS was, okay, so the existing PDF was slow to graph millions of lines. There's a threshold. The bigger the clients were getting, the more TPS tracing the developers were putting in, the more we're getting into thousands to millions to hundreds of millions of lines we're pouring out. Putting hundreds of millions of lines in a PDF, it's not realistic, okay? So then what we said there, you couldn't zoom on the graph, and experts are always needed for analysis. So basically, you drop in your log drop, and you don't get a nice kind of green, orange, red, there's a problem here. You needed an expert who's in the company 5-6 years to dig into it, and it was a problem. So we wanted everyone to do this, okay? So what we did was, we tried to invent something in Splunk that everyone could use, okay? So this is a quick, 5 1-minute videos, and in this is what we developed in Splunk. So here you can see the class name, okay? Over here you see the method name. So this is like a 3-minute test, and it displays every class and every method name. The idea is that the developer logs in here, and he's able to see all his mathematics and all his quants that he wants. And again, we graph it here. So 1605, so that's a 6-minute test. And you can see it goes up 10, 100, 1,000 milliseconds in 1 second. Okay? And you can see the time of each fully quantified method. 600, 700 milliseconds. Okay? And then you come down here and you have your mathematics. So you have your average here, 810 milliseconds. You have your count, 15,000 counts, your standard deviation. All these mathematics are very, very important when you're trying to get these numbers right down to absolute millisecond speed, basically, okay? And the next thing I'm going to talk about, you can also zoom in. So see the way I pinched on the graph there? I say zoom on selection, so it zooms right in to that particular selection. And again, I want to zoom in again. And again, when I do that, the mathematics update dynamically, okay? So it's an interactive dynamic dashboard that now the developer can pick the part of the test he wants to see, and everything just updates in real time. And again, if the developer actually wants to see the actual log coming out, he clicks on the graph, and he actually gets the actual log that came out the back. There's millions of lines of these, but sometimes the developers are not convinced it's working properly, and they want to see the log, right? So you can't take away the log from developers, otherwise they'll just go back to their old way. So you have to take into your mind, what were they doing? They were looking at logs. You can't just take that away from them. You have to also provide the logs, okay? So if they want to say, you know, oh, don't believe it, because all of a sudden you roll in a system like this, very quickly they don't like it and no one uses it, okay? So you have a lot of interviews with the developers to get it up and running, okay? So this is a test. It's over 4 minutes long. Can anyone tell me what's wrong with that test? If you're looking at the time. I'll give you a hint. It's increasing over time. Exactly, right? So basically it started out here, okay? You're going up here, there's a slight linear increase, okay? Now it's a 4-minute test, and what's going to happen if at night time when these banks recrunch their numbers, they could do an import that could last 1 hour. All of a sudden that gets really, really long, and there's a problem. The average is 800, but the developer is making this. The developer, if he doesn't graph it, and he only looks at these averages, he mightn't think to himself, that's a problem. He might think during the development life cycle, he might go 800 milliseconds, that's fine. But then he might ask business and he'd say, well, what's the KPI here for this new module? Sometimes business don't know. They don't have a hard KPI for a new module because it hasn't been used in the industry. So they can't give him an answer. So then all of a sudden, the developer goes, that's fine, that's a pass. I know it's red there, but he goes, that's a pass, that's fine. Because he hasn't seen this graph. That's the point, okay? But when you put these graphs in front of them and you can do trend analysis on performance, all of a sudden these things become a lot easier to see. And when we're doing our product development for our very, very performant product, when we start using this, we start seeing a lot of problems that we wouldn't have seen before, okay? So, yeah. So again, as I said, there's 1,000, 2,000s. We can see the graph is trending upwards. And you can click on any one of the quantified methods, class.method, and you can see some trend upwards, some don't. Okay, but you can get a better insight to that 4-minute test. And again, you get your mathematics, and that's fine. so you can understand everything. But more importantly, the second concept I'm going to introduce now is something we call Splunk ID. So I'm a tester, and I want the developer to look at that. So I can zoom on selection, and it zooms in. But I want to see this peak, specifically this peak. Why is it taking 3 seconds? And I want to send that to the developer. Okay. Now I want him to see that in at most 5 seconds. I can make something called a Splunk ID. Okay. So I'm going to put in here SoftTest version 5, and that's going to save. It's going to save the timeline and the data point that I'm on. So the data point could be dev test, whatever. You can put in like dev optimization, function optimization, index remove, because sometimes you want to write like every time you do a test. It's a good time to pause it there actually. Every time you do a test, every time you do a Splunk ID, you want to get the start time, the stop time. You also record the version of the product, because often when you're doing tests, you're doing hundreds of tests, and the binaries are flying in, and you can't remember which binary you tested on which. So you have to be able to very quickly, automatically record every test instantly. And the whole point behind this is what I'm highlighting here. It's called a Splunk ID. And this is an ID that me as a tester, I can save that. I email that ID to the developer, and the developer just pops in the URL, presses enter, and within maybe 10 seconds is looking at the exact problem I'm looking at. And that's an interactive dashboard. I'm not sending him a screenshot and saying, what do you think it is? I'm sending him an interactive dashboard that he can now drill into any point he wants, because he's the developer, and I want him to understand why is that slow, basically, okay? And then from there, he can go further or not, okay? So that was one of the features that we created, Splunk ID. We found that very, very good for getting all our developers or all our test campaigns. The concept is brilliant, because now when you're doing any test campaign, if you want to look at a test you did 6 months ago, you have a URL, press one button, in 10 seconds, you can see all the data points you want. That's it, straight away. And you can do further investigation. Okay. So, use case 1. So, how is this useful to us? Murex had a very, very large prospect. They wanted us to do 60 trades per second. So that's 17 milliseconds per trade. Okay, 1,000 milliseconds in a second. Okay, that was challenging for us at the time. Now you have to remember, it always depends on the client. Each client is different configuration. Some clients are simple. Some clients are hugely complex with mathematics. Okay, so every client we tailor to. Okay, so by using Splunk, we were able to overlap different data sets. Okay, so TPS tracing, overlapping on top of garbage collection. Now, to explain quickly about garbage collection, I'll go back there actually. So, we program garbage collection, we don't program garbage collection. We're Java. Java produces something called garbage collection. Very simply, without giving everyone, you can write PhDs in garbage collection, so I'm not going to give that speech tonight. But there is a certain thing in garbage collection that stops the world. So you are doing something that you are opening a limits modeler. The garbage collection goes, oh hold on, a certain bound is breached, I have to run this, stop the world. It will stop for a few milliseconds or 100 milliseconds or half a minute, the JVM process even moving, okay? And that's fine, and you don't see that if you're doing opening screens, but you do see that if you hit 17 milliseconds, okay? At a very, very high throughput. This stop the world algorithm is extremely dangerous and adds a lot of volatility to this type of activity. And that's exactly what we saw. So in green here are the trades going into the system. Remember, 17 milliseconds is the KPI. There's 10 milliseconds. We're about maybe 70 milliseconds at normal. And the green peaks are about maybe 900. The purple beside it is garbage collection. And you can see they're all married, practically all married. Okay? And that means that the Java is doing garbage collection at the same time that we're trying to insert the trade, and it's blowing this KPI right out of the water. Now, it sounds very easy. I suppose everything's easy once the graph is up. But initially we weren't really looking at this kind of, so what we're doing is we're overlapping two data sets. One data set recording how fast our product is, the other data set is recording Java. Okay? And then when we did that, we found very quickly the problem that we had. Okay? And then okay, so we broke it down to this is a very simple one now. There's only one TPS tracing on in this particular case. It's about a 5-minute test. The average initially was 99 milliseconds. Okay, it was way too long. The throughput is 5 trades a minute. In fact, we're nowhere near the 60 trades in this particular case. And we can see we have 51 milliseconds, 51, 51, and some peaks of up to 1,000. When we interact with the system and overlap the garbage collection and say, like, we are investigating, why is it so slow? I programmed the maths to pick this up. It overlaps the two, sums the two, and 50% of the time is spent garbage collection, where it should be doing trade insertion. Okay? And then we can zoom in and you see the same graph that I just showed you there a minute ago. So 698 milliseconds and 612 milliseconds, quite simply, all the time has been spent in garbage collection. Okay? And it took us a while to kind of figure it out, and it was only because we had Splunk that we were able to pretty much overlap the two. So again, 50%, a total 50% taking too much time. And the 99 is too much. Now this is the solution slide up here. So after a month of kind of changing garbage collection settings, changing the functional product, and changing other things, we reran the test, major new binaries. That's down to 7% now, great. That's down to 0.08. We still get some garbage collection, but you can see the average time is much, much, much lower. Okay? And effectively, you go back to the bank and say you've hit the KPI. The banks are ruthless with these KPIs. If they give you a KPI, there's no kind of, we can't hit it. You either hit it or you don't. Or they got the next guy. Do you know what I mean? That's simple. So, they're very, very ruthless with this stuff. Okay, so basically we hit the KPI for that and everyone, basically we were all happy. And that was about, it looks simple there now, but it took a lot of weekends and late nights to get that to finally there. Okay, so that's use case 1, use case 2. Let's check the time here, guys. Okay, nearly out. Use case 2, the last use case I'm going to show you. It's something called a Gantt chart zoom. And what we did in this particular case is that sometimes a client was complaining that the trades were taking 10 seconds. 10 seconds is an infinity in this business. So the client said, this is ridiculous, Murex, we need this to go faster. So we get this graph and we're showing the developers this stuff and they're like, it's okay, Robbie, but we need more. Like, I can't tell the problem from this. So then we develop what we call a Gantt chart zoom. So we effectively chronologically map out the time of each class.method. Okay, so that guy basically calls this guy, which calls this guy, and you notice that the graph goes this way, basically, okay, as we get down deeper and deeper. So effectively you could see in a nice way exactly who's calling what and going down. And then we stumble upon a problem. So, well, why are we hitting the database so much? Okay, you can really see it here, is that like, we're interacting with the DB way too much here. So, well, why does this exist? Murex.db.selector. So, did it say, well, this is exactly the problem? No, but it helped us find, with this type of solution, exactly where the problem could be. And you can see time goes all the way down. So that's a 14-second window that you were looking at. And you chronologically map the time all the way down, which basically helps the development team find it real quick. Okay? And then the last thing I'm going to show you, okay, is identifying different tests on a timeline. Say I'm a tester and I run 20 tests at night. I go home, I come back in. I have an x-axis with lines on the graph. I generally don't, I'm like, where's test 1, where's test 2, where's test 3? So we had to develop a way in Splunk. Now, to be honest, like, none of this came natural to Splunk. We developed all this ourselves and we applied it. So like Splunk doesn't come with this kind of toolkit. Basically, we developed it all. And in fact, when we showed it to Splunk themselves, they themselves were amazed that we've gone to such a level with their own product. Because they don't use it this way. It's a very unusual way to use Splunk, basically. Okay? And so when we developed it here, we developed this on-off tag, and you get this nice test 1, test 2, and you can see very clearly the different tests that ran. So for example, that could have been an import test, this could have been whatever, a restart test, but you can see the different tests are mapped out nicely. Okay? And then I'll show you the last video. That we find this good. Our test was like this one. This test could last maybe an hour. So we get the overhang that the test lasted an hour, and we turn on the events, and we come down and we can see how long each event took. So you might start the system, stop the system, turn on the CPU, sleep for a bit. But again, we also put that into a Gantt chart. So you can see the overall test maybe took an hour and a half. We stopped the system, it took 2 minutes to stop the system. We that stopped the system. We slept for 120. You cleaned the logs. We data mined the database, and then we did the big long import that took an hour and a half. And then if you want to, you can click on one of these logs, and you get the log that's produced straight out. So you don't have to be using Notepad++ to be opening up log upon log. But how long do your testers spend opening up logs? Everyone does it. Put it all through Splunk. So you can just click on it, you get a full event line, everything that runs in parallel or not. You click on a button and you get your log out. So if it fails, you see straight away it failed because of this reason. You don't have to open up log upon log. And you can put filters on that, check for error, check for warning, etc., etc. So it really depends on what you want to do with it. As I said, it's a toolkit, okay? And then coming up to the last slide now, maybe hitting the 30 guards. Hang on, there, maybe. Okay, so in conclusion, the Splunk TPS view, what has it achieved? We had a problem. We need to view millions and millions of data TPS tracing quickly. We got it down to about 7 million lines in 7 seconds. In fact, we can do more now. So that's the kind of the volumes that we can handle. We need to get data into Splunk quickly. We can get any data from any Murex site or globally into the system within 20 seconds. So that can just like zoom in, right? And then it takes about maybe 2 minutes to display, okay? But that took a lot of work to get the indexes running strong, running quickly. Problem, we need to overlap different data sets so we can overlap CPU network because we're trying to find bottlenecks. So you have so much data coming out, you overlap them all, and then bottlenecks become very obvious, basically. Well, they do and they don't, right? If they became very obvious, they wouldn't have a job, right? But we try to make them obvious, okay? And then we throw indicators saying red, green, orange. If there's a problem here, there's not. Problem, how can I show my other teammates what I'm looking at, the Splunk ID? You just make a Splunk ID and then shoot it to them. And the idea is that they just get that ID, and then forever that Splunk ID is in the system. And then they just take it, and then they have it forever. Okay? Thank you.